In this video, we will look at the finite representation of the language and the typical architecture of any finite machine. Any finite machine consists of mainly three components, which is the input tape head, and finite control. Basically, the input tape has the input string, and it is this input string that you want to determine whether it is the part of the language or not. And the tape head is pointing at different times. It will be pointing to one of the symbols of this string. So tape head is basically reading the string from left to right. In most cases of a finite machine, we will see that tape head will read from left to right, except in the Turing machine it can go both ways, from right to left also. And tape head typically only read the symbol, except again in Turing machine we will see that it can write also. In most of the cases, the tape head will read the input from left to right. And there is another component which is the finite control, and in the finite control actually we have the states. And finite representation of what we mean by finite representation of languages, what we mean by finite representation of languages is that there is going to be finite number of states. So finite representation of implies finite number of states in the finite control. And finite control has the logic for state transition. So at any point of time, your machine is supposed to be at one of the state. And through some criteria, means, okay, look at what is the configuration of the machine. At any point of time, the machine is said to have some configuration. And which is what? So your tape head would be pointing at some symbol. Your machine would be at some of the state, at one of the state. This constitute what we call as the configuration of the machine. So let me take this example. So at time t, your tape head would be pointing to some symbol in the input string. Okay, and your machine would be at one of the state. One of the state. This is what we call as the configuration of the machine. Okay, and finite control has the logic for state transition. What I mean is that when you are at a certain state and your tape head is pointing to some symbol, so based on let's say your string is input string is A B B. Let's say this is your input string. Okay, at any time this is your configuration. Now your tape head, based on what symbol your tape head is pointing to and what state your machine is, typically you have a move defined, and based on that you will go from one state to another. So based on some criteria, like what the symbol at tape head is, what the current state is, the finite control will move from one state to other, or it may remains in the same state. Okay, and when you have a state transition, simultaneously tape head also moves with state transition, one step to the right in most cases. And this is what we call as the change in the configuration of the machine. So when you are at, let's say time t1, your tape head is pointing to the input symbol B, and you are at state q1. So this is your configuration at time t1. So based on this, you will go to some other state. Let's say the move is that if at q1 the input symbol is B, then it will go to q2. Then this is what it is. So when you move to Q, okay, you are at Q1, let's say this was the B that tape head was pointing to, and you are at Q1. So at time t, this was the state. This was the configuration. Q1 and B at time t. This was the configuration. And at time t2, what would the configuration be? This will be the symbol that tape head is pointing to, and the state is Q2. So there is a change in configuration. There is change in configuration. This is what a typical finite automata is. In the next video, we will see in brief deterministic finite automata. But before that, there is one more thing. Let me give you a little insight over what the states are supposed to be. So when you are designing the finite automata, each state will signify something. Each state depends on what your language is, because you will in a finite machine, the machine only knows that from one state to see a symbol, it has to go to some other state. It is you as a designer who will fix that move. It is you as a designer who will define those moves in such a way that you will give a DFA for the language. One thing. Second thing, and in your attempt of designing DFA, you will make sure that each state in your mind will be representing something. Each state in your mind would be such that when you are traversing the string, and let's say if you are at Q1, it means that your traversed string so far has satisfied some pattern. Means there is some pattern in that string. There is a confirmed pattern in the string traversed so far. Okay. Being at any state, let's say if you are at state Q1, it confirms that for the traverse string there was some pattern that is observed so far. So each state confirms that, and it will be clear when we will be designing different DFAs. We will take examples of DFA, examples of language, and we will be designing DFA for it. Okay, thank you very much.